which of course adds significantly to the weight of the building and to the cost. The strength of wood varies significantly. Different types of wood have different strength ratings to them. A very soft wood such as pine or southern pine or Douglas fir, which is typically used in building in Type 5 construction buildings and also in other types, is what's common, but it's a very soft wood. Obviously going with an oak or a hickory or some other type of hardwood would provide some additional strength, although it can also be brittle. So that's why the builders stick primarily with Douglas fir. The wood can also be treated with fire retardant chemicals. There is a trade-off there also, but the fire retardant chemicals can inhibit fire spread if the fire gets into the walls of a wood frame building. There are some issues with the spray-on coatings and actually contributing to early failure of roofing components, and some of those products have been taken off the market as such. We're going to look at the common forms of wood products, not just structural lumber, but also some other things that go into a wood frame building. The most common wood that we're familiar with is going to be either boards or dimensional lumber. About the only real distinction here between boards and dimensional lumber are that boards are typically wider than they are thick, and they are generally pretty thin. We're talking usually 1-inch boards or perhaps a bit thicker, but not very much more. Boards were used for sheathing and for roof decking in the early part of the 1900s because of their widespread availability and the fact that plywood was not available in large quantities at a reasonable price. Now, after about 1945, or the end of World War II, is when we started seeing plywood coming in. And now dimensional lumber is our typical sawed 2x4s, 2x6s, 2x8s, 2x10s, and so forth. This is what we commonly use in the common stick-built Type 5 building. And then we have our timbers, which are going to be, again, going back to the Type 4 or heavy timber or mill construction, will be structural members that are a minimum of 8 inches by 8 inches. Anything that is smaller in dimension on in any direction than 8 inches is not considered to be heavy timber construction. Then we have our laminated members. This has become very popular in recent years. Small flat strips of wood that are glued together and clamped together under very high pressure, sometimes bent into an angle that is not achievable with traditional wood, hewn logs or sawmilled logs. There's great advantages to the using laminated members in today's construction. They are extremely strong. They permit us to build structural components under very tight tolerances and permits very high quality control. The disadvantages, however, of some of the laminated members is if they get exposed to any type of moisture. A roof leak, for example, can affect some of these glue laminated structural members and affect the glue that is the very thing holding those beams together, and can cause premature failure, as can insect infestation or just plain rot from being allowed to be in a damp environment. Oops, sorry. We have various types of panels. We have plywood panels that are used for roofs, subflooring, and siding. Require a lot less labor to put up sheets of plywood than putting up, say, 1x6 pine boards. Also much more economical. And these are graded for structural use and for exposure durability. Plywood is not plywood is not plywood. There are many various grades of plywood, some delineated for structural use and others for strictly cosmetic purposes. Manufactured members are prefabricated from components and then shipped to the construction site for erection. What we see here, the most common manufactured members, of course, are roof trusses. Roof trusses are assembled in a factory under very tight quality control. When you get a truckload of roof trusses in for a building, they are all exactly the same dimension and size. Allows for, like I said, very, very good quality control. They're very light. They're engineered as a system, and they're very, very effective, and it allows the builder to build a building very rapidly with a lot less skilled labor. And they are commonly used, as I mentioned, in peaked roof in residential construction and also some commercial, but also we're starting to see parallel cord truss assemblies going into floor systems in commercial buildings now. It's very common. We'll look at some of the ways that in Objective 3 that manufacturers have found to reduce the combustibility of wood. Of course, one of the major problems with building a building out of wood is that wood, of course, does catch fire. And once it catches fire, it's going to burn significantly until it either runs out of fuel or we put some water on it or some other extinguishing agent to extinguish the fire. Fire retardant treatments are permitted by building codes for certain applications. We can treat some wood to resist ignition or to increase the amount of time that wood will last under direct fire impingement, and should not be confused with materials that are fire resistive. Because remember, if you go back to our type 2 building construction, fire resistive components will not burn. Type 2 fire resistant building is built of components that will not burn, and that just by its own definition precludes the use of wood. So there is no wood being used in a type 2 building. Surface coatings applied to wood primarily used to reduce the surface burning of wood. Direct flame impingement upon a piece of wood that has some type of a surface coating will take much longer for that structural member to catch fire itself than the non-treated wood of the same dimension and surface area wood. Another process is pressure impregnation. There's a number of fire retardant chemicals that can be used this way, where the wood members are actually put into a chamber and a fire resistive chemical is then introduced into that chamber under very high pressure and literally presses the chemical down into the pores of the wood. Kind of like your grandmother's pressure cooker for how she used to cook chicken back in the day. It's the same concept. They raise the pressure inside that vessel with the chemical in there and just presses that retardant down into the pores of the wood. Now we're going to look at some of the forms in which masonry materials are produced, because masonry building unit members are not all the same. They are all created very differently. Masonry members is one of the most fundamental construction techniques. It dates back to ancient times. It simply refers to stacking individual units on top of one another and bonding them into a solid mass. Now, in ancient times, builders attempted to build buildings without any type of mortar. They just stacked bricks or the stones one upon another, and it worked for a while, but then it found that in the long run it didn't work very well. So they started using mortar, a limestone mortar mix to put in between their units. Masonry walls are inherently resistant to fire and insects. After a fire in a masonry building, pretty much the masonry will be unscathed. It may be scorched a little bit, but it will retain its structural integrity. And insects, of course, are not going to eat masonry members. Disadvantages are that masonry buildings are heavy, and they do require some skilled labor to lay the bricks or blocks in place and do so in an even and uniform manner so that the building maintains its structural integrity. And they do require mortar to joint the blocks together. Brick is another type of masonry building produced from a variety of locally available clay and shale. Here in Pennsylvania, there's a great deal of brick construction because there is such a high clay content in our soil. It is not difficult to dig down just about anywhere in Pennsylvania and find clay. Well, brick manufacturers take the clay that is found naturally occurring in the ground, uh, place the clay into molds, and form the bricks under high pressure, and then drying them in a kiln where the bricks are baked to a very high temperature, takes all the moisture out of it, and actually converts that clay into a hard ceramic material that is now suitable for the builder's use. Concrete block, on the other hand, are cast in place. The concrete is mixed up and poured into a mold, and it forms the concrete block, usually hollow. And then these are, again, the quality control is very good because the blocks are made under very tight quality control conditions. And then they are simply stacked in place and then mortared into larger units. Stone, again, going back to ancient times, ancient stonemasons would cut pieces of rock out of a quarry in the ground, cut them to the desired shape and size, and then they could be assembled on site for the builder. It's one of the principal types of building construction. Again, dates back to prehistoric times, really, and is still in use today. It is expensive and it is heavy, and other types of masonry construction, such as the cast concrete block, are far more economical for today's builder. Clay tile block is used for foundations and walls where clay is available. This was a very popular technique in the early part of the 1900s. Clay tile block was used, or sometimes referred to as backing tile, was used in the center for the actual structural members of the building, and then plaster applied over it on the inside, and perhaps a brick face on the outside. One of the disadvantages to clay tile block, even though they are baked or are produced in a kiln just like a brick is, they do deteriorate over time, and they are susceptible to damage. If water gets inside one of those clay tile blocks and then freezes, it will split the tile block and it will compromise the integrity of the tile. Gypsum blocks have really gone out of favor in modern practice. We'll still see them in some older buildings. Used primarily for internal partitions, they are not applicable for exterior use. With a gypsum block, as soon as they get any significant amount of water on them, they tend to crumble and start losing their structural integrity very rapidly. So therefore, they're not used outside. We're going to look at the use of concrete as a building material. Very widespread use today. There are very many types of concrete, but they are all produced from some combination of Portland cement, coarse and fine aggregates or gravel, and a certain amount of water. And the strength of that concrete depends on the mixture, depends on reinforcement. Here in the photo we see reinforcing rods or rebar. Excuse me, being put in place here with the with this footer and getting ready to pour some concrete wall. And then also the water to cement ratio is very important. You'll hear terms such as 6,000 pound concrete or 4,000 pound concrete. Refers to the amount of compressive strength that is per square foot, and the 6,000 pound concrete would be more appropriate for a driveway, where the 4,000 would be more appropriate for a sidewalk that is not going to be driven on. Now we're going to look at steel. Steel, like every other building component, has some distinct advantages and some disadvantages as a construction material. One of the advantages of steel is their low carbon content. It's one of the strongest materials used today. Again, manufactured in a factory environment under very tight quality control. But it is relatively expensive. The good news is that building a steel building does not require a great deal of steel. As you can see in the example in the photo here, the steel structural members can be quite spread out in some cases, and in others we want them a little bit closer for more rigidity. The disadvantage of steel, of course, looking at the photo here, this is obviously a Type 3 building after the fire, and you can see where the steel has lost its structural integrity as it was heated by the heat of the fire. Steel will also tend to rust, and it will deteriorate over time in a moist environment if it's not protected. It is not uncommon at all for steel structural members to rust and lose much or all of its strength while the concrete poured above it still is intact. And that does not mean that the building is not structurally deficient. Once that steel loses its integrity, there are serious structural issues with that building. Now, as we talked about in the Type 1 building construction, the most common method of protecting steel in a Type 1 fire-resistive building is to completely encase it in concrete. But of course that's expensive because we have to now use two building construction methods in order to build the same building. So as a result, some other methods have come around to protect steel in a Type 1 building. We have lightweight materials that can be troweled on or sprayed onto the steel. And we have also some intumescent coatings, which are, it's a fancy word for a very special type of paint that can be applied to structural steel, which when heated expands and provides an insulating blanket around the structural steel of the building. There are other metals, of course, used in building construction today. Lots of aluminum being used. It's limited in use, however, by several factors. Number one, aluminum is still relatively expensive compared to steel. It also will melt under fire conditions. It does not, even though steel will melt under fire conditions, the temperatures required to make aluminum fail are much lower. And if aluminum is used for roofing, it does not provide a safe surface for firefighters. It can be very slippery. And aluminum is also an excellent conductor of electricity, another hazard to firefighters. We saw a lot of cast iron used in the 18 and 1900s. Problem with cast iron is it is brittle, it will crack and tend to fail very rapidly under any type of a load that it was not anticipated. In other words, a building using cast iron to hold wooden structural members together may not withstand an earthquake as well as something that used steel, because cast iron is relatively brittle. Copper is fallen out of favor just because of the expense of copper, but in earlier times it was quite extensively used for either roof sheeting or for gutters and downspouts. Nowadays it's largely used for decorative purposes in very small quantities. Zinc was also used. Galvanized material is all composed of zinc. It's limited in use. It's used for primarily for coating of nails that are going to be used in an area where moisture is going to be an issue. In other words, any nail used in an outdoor environment or in a roofing environment is going to be zinc coated or galvanized. Now we'll look at some of the uses of glass in building construction. We have ordinary single strength annealed glass, or window glass that we refer to. We have heat strengthened glass, which is partially tempered glass, fully tempered glass, also laminated glass and glass block. Laminated glass is a special animal. It's actually got multiple layers of glass with a plastic sheet in between it. Now you can't see the plastic sheet, but car windshields for decades have been used of laminated glass, and the idea was in a collision to keep the passengers in the vehicle. Well, it failed miserably because generally speaking, folks were ejected right through and took the windshield with them when they were ejected out of the car. But tempered glass is used typically in buildings today within 6 feet of any door in a building, in a commercial building. That glass needs to be tempered glass because even if you were to successfully break a tempered glass window, it shatters into a million little diamond-like crystals, and while you'll still get cut from it, you will not get cut to the same damage as you would going through a plate glass window. So plate glass window has pretty much been outlawed anywhere where you could put your hand through it in a commercial building. Using glass where there's fire resistance requires use of one of two special types of glass, either fire-rated glass, which is a very expensive form of tempered glass, or wired glass. Depending on your age, when you went to school in an elementary school, you probably saw some of the stairwells had been enclosed with a combination of steel and glass, and that glass generally had wire embedded in it in between the layers of glass. Might have looked like chicken wire, or it might have been square grates. The purpose of that is that glass will not fail as readily under fire conditions. It takes a great deal of heat for that glass to fail because of having that steel impregnated in between the layers. Now, gypsum board. Gypsum board has, or commonly referred to as drywall, has really taken over in the interior finish business, because virtually every building built today uses drywall in it for the interior wall finish. And gypsum really took over in the 1960s from the concept of using wood lath or strips of wood nailed to the structural members, and then applying plaster over top of the lath and just troweling it on, and then providing a smooth surface in the plaster. Gypsum board is extremely inexpensive. It's a great substitute for the lath and plaster technique, which again requires a craftsman to install. It's used in fire-resistive assemblies. You can double up on the certain types of drywall, and it provides a fire-rated assembly. It's produced in mass quantities and very readily available, and it does have some limited protection for the structural members when exposed to fire. Many types and applications of gypsum board. You have regular, you have water-resistant board, type X and type C, foil back, gypsum backing board, core board, and many others. Some of the others not listed here that you'll see in construction would either be green board or blue board, which are mildew and water-resistant types of boards, typically used in bathrooms or used in shower stalls behind the tile and so forth. We'll look at some of the use of plastic construction materials. Plastic is used, formed with organic materials and formed by pressure, heat extrusion, and other methods. We don't normally think about what goes into plastic, but virtually all plastic is made out of some type of petroleum or an oil product. Plastic is used today, many different types of plastic, used for a number of construction components, and just about as far as your imagine can go is the number of things that they can build out of plastic for use in constructing a building today. The strength of some plastics is very close to wood. There's a very good reason why it's not used for structural applications, because it does melt, it does catch fire. It is increasing in use. There are some flammability issues, as mentioned, fire hazards and thermal barriers. One of the things that you have to watch with plastic construction materials is if you use plastic in a building anywhere where part of the building might become part of the heating, ventilation, and air conditioning system, then that plastic has to be a special type of plastic that does not give off toxic fumes when heated. Again, adds to the cost of the building. We'll look at the uses, advantages, and disadvantages of fabric as a construction material. Part of the fabrics used in part of the enclosing surfaces of structures such as membrane structures or tents. It can be used as part of the existing walls and roofs of permanent and semi-permanent structures. We see fabric being used a lot for large assembly occupancies like convention centers and auditoriums and sporting arenas. And of course, all these fabrics have to be meet certain standards in terms of fire resistance and flammability. Some of the advantages of fabric is it's much lighter than other types of materials, typically for roofing. It erects in very much less time. Putting a tent up takes a whole lot less time than building the building. Using the tent analogy is, of course, a gross over-exaggeration. Fabric can flex and absorb if there were to be any type of earthquake activity or extreme wind forces, the fabric will give much more than a rigid building will. And it also gives us the ability to develop some really interesting architecture and some really neat shapes in our buildings. One of the disadvantages of fabric: it can't support a compressive force. By compressive force, we mean you can't really stack something on top of a fabric structural member because it just doesn't have strength in that direction. It has to have some type of an internal cage or support system to hold it up, and can't be used to hold up building appliances such as heating, ventilation, and air conditioning components. Where we could put HVAC units on the roof of a conventional building, a building with a fabric roof, that's not the case.